Is finished, viewers. So yesterday we have learned the physics, and I hope so that you have gone through the revision and you have done diagrams and the concepts, the lesson wise, whichever I told you to revise that you have gone through that one. So the next thing, the second part is a chemistry, and in the chemistry you will get 25 marks, and the question number, it will start from the 13 and till 25 it will be the part B chemistry. Okay, then in the chemistry totally we have the 4 chapters, and out of 4 chapter we have 4 diagrams. So that 4 diagrams, out of that 4 diagrams, in your exam compulsory you will get 2 diagrams. So keep it in mind, out of 4 at least 2 diagrams are appear in your final, and the diagrams I have highlighted here. One is your electrolysis of water, second reaction of zinc granule with the dilute sulfuric acid, and the third action of steam on the metal, and the fourth will be the electrolytic refining of the copper. So out of this 4, 2 diagram compulsory you will get it, and the 2 diagram here, as you are observing, 25 marks. Out of 25, 5 marks you will get it for the diagrams. Did you got? Yesterday we have learned physics. In the 27 you will get 6 to 7 marks for the diagram, but here in the chemistry we will get 5 mark diagram, 3 mark 1 diagram and 2 mark 1 diagram. 3 mark diagram in sense we can expect from the metal and from the acid, bases and salt. Okay, it will be a 3 mark diagram, and even this too also a 3 mark diagram only, but sometime any 1 part or 2 part they will say you to label, and even they can make it for the 2 mark diagram here. Okay, so let us move on to the chapter wise. What are the important things you have to learn for your exam? So the first one, in the chemical reactions and the equations. So in that, this 4 areas to be covered. So first one is a balancing of equations. I hope so that every one of you know how to do the balancing of equation. Yes? Okay. And now the question will arise, which equations we have to learn for balancing. So listen here. First you have to go through with your 4 model paper, in that which equations are there, which is said to be as a balance. So practice that first. Then analyze your state level, district level, taluk level preparatory. In that also, if you are getting the question to balance, then go through it. Then apart from that one, yesterday in your group I have forwarded one PDF. In that also you have some equations which is to be balanced. So if you are perfect with that, so we have observed in the some model paper that 2 mark or 3 mark it is appearing for balancing. So first learn balancing of equations and become perfect with that one. And moreover, in any final paper if you observe, they are giving the balancing of equation, not a complicated equation that you have seen in your exercise. That is a bracket type of equation. That type of equation they are not giving for balance. Only they are giving very simple equations. So that only I am advising you, go through with your model paper, district, taluk and state level preparatory, and yesterday the equations which I have shared in your group. Then second part you have to learn is the type of chemical reactions with examples. So totally we have major how many types of chemical reactions? It is 4 types. Okay, so the first one is chemical combination reaction. So learn the definition with example. Okay, and when you are learning the combination, inside combination there is another one reaction. Do you know that? Which is that? Exothermic or endothermic, which will come under combination? CaO plus H2O, it forms CaOH twice. It is an example for which? Exothermic or endothermic? It is exothermic. Adding, that is a calcium oxide to the water, and if you stir, it become hot. I have shown that equations and the diagram based question also. So it is a what type of equation? Exothermic, and even it is an example for combination reaction. So when you are learning combination, learn even exothermic reactions. Okay, and even there is one applied question also we have. Why respiration is called exothermic reaction? Because during respiration, oxidation of glucose takes place and release the energy in the form of heat. Hence, respiration is called exothermic reaction. Decomposition of that is a biodegradable matter, it is also a exothermic reaction. So go through this applied base exothermic reaction. Then second type of reaction is chemical decomposition reaction. Okay, definition and example. But when you are learning the decomposition reaction, inside decomposition, 3 types of decomposition are there, plus along with that even we have endothermic reaction. So what are those which is there in inside the endothermic, that is chemical decomposition? There are 3 types of decomposition reaction. First one is thermal decomposition. Second one, electrolytic decomposition. Third, photochemical decomposition. Okay. So when you are learning thermal decomposition is also a example for endothermic or exothermic? Endothermic reaction. Okay, so you have an equation CaCO3, on heating it forms CaO plus CO2. It is endothermic reaction. So thermal decomposition reactions are all example for endothermic reaction. And the heating ferrous sulfate crystals, it is also example for endothermic reaction. Heating lead nitrate is also example for endothermic reaction. And this 3 equation, CaCO3 on heating, FeSO4 on heating, and PbNO3 on heating, lead nitrate on heating, go through this one, because sometime they will say to translate word equation to symbol equation. So to translate the word equation to symbolic equation, these 3 equations are very important. CaCO3 on heating, FeSO4 on heating, and lead nitrate on heating. Because these questions have already appeared in your finals. Okay. Then some hidden points to be remembered. When you are heating ferrous sulfate crystals, it will release the pungent gas. So that pungent gas is a sulfur dioxide gas. And when you are heating the lead nitrate, it releases the brown color gas. That brown color gas is nitrogen dioxide, NO2 gas it is. You got? So calcium carbonate on heating, it releases which gas? Carbon dioxide gas. So these are the hidden points to be remembered about the 3 equation. The next electrolytic decomposition, that is electrolysis of water. And the 3-mark question can also be appeared on the diagram based on electrolysis of water. So I think you are all familiar with that. So in that electrolysis of water diagram, which gases are released at the anode and cathode? hydrogen and oxygen. Which gas is more? Hydrogen is more, oxygen is less. And for that reason also you know that why hydrogen is more and why oxygen is less for that one. Have you got it? So remember that it is a 3-mark question on electrolysis of water. Then next to that one, after electrolysis of water based question, then third type of decomposition is a photochemical decomposition. So for the photochemical decomposition, two equations are required to be remembered. First one is a silver chloride equation and another one is silver bromide equation. 2AgCl, that equation. So 2AgCl on exposing to the sunlight, it forms 2Ag plus Cl2. And this silver chloride is which color chemical? It is a white, and then on exposing to the sunlight it will turn into gray color, because these are all the hidden points. If you remember the color, gases, if they give the applied base question also, you can track and you can solve it. So it is a white color chemical, but on exposing to the sunlight it will turn into which color? Gray color it will be. Then next silver bromide, 2AgBr, on exposing to sunlight it will become 2Ag plus Br2. And this silver bromide chemical is used for which type of photography? Color or black and white? Black and white photography. So black and white photography related to silver bromide, and that white to gray color, that point to be remember about the silver chloride. And these two chemicals also we should have to store it in the dark bottles. Why we had to store this one in the dark bottle? Because if we expose them into the sunlight, they will undergo photochemical decomposition. Hence we had to store it in dark bottles. Okay, this question also have been appeared, so that only I am revising everything. Then third type of chemical reaction we have is a displacement. So displacement, there are so many examples are there. In that, that is a copper sulfate equation to be remember, zinc sulfate equation to be remember, and lead, that is a PbNO3. That equation is also an example for the displacement reaction only. So CuSO4, copper sulfate is a blue color solution. On keeping the iron nail, it will turn into green color. So it is a displacement. ZnSO4 plus Cu, this is also a displacement reaction. So in wherever you are finding more reactive element is displacing the lesser one, so it is all the displacement only. Then last fourth type of reaction is double displacement reaction, and in the entire textbook only one equation is there for double displacement reaction. So what is that? Sodium sulfate react with barium chloride. So that only one equation. So sodium sulfate react with barium chloride, it will form sodium sulfate, barium sulfate and the sodium chloride salt. So which is that white precipitate is been formed. In that equation there is a formation of white precipitate. Which is that white precipitate? It is a barium sulfate. Remember this one. And this double displacement reaction takes place in two steps. First step is a neutralization and the second step is a precipitation. So remember, double displacement, it will occur in two steps. One is a neutralization and another one is precipitation. So because of mutual exchange of ion, white precipitate is been formed. So that ions which has been that is exchanged, it is a barium and sulfate, they are exchanged and it have been become the barium sulfate as a white precipitate. Did you got it? So this is a second part you have to learn as a types of chemical reaction with example. Then the third one is redox reaction. What is redox? What is redox reaction? A reaction in which both oxidation and even reduction. In a single reaction, if we have the both oxidation and reduction, then it will be considered as what? Redox reaction. Okay, you have seen the questions in your question paper. They'll give the equation and they'll say you identify who is oxidized and who is reduced. So practice one such equations in which redox reaction is takes place there. Then final thing to be learned in the chemical reactions and equation is a rancidity and the corrosion concept. So what is rancidity and how to avoid the rancidity? Which is a inert gas which has been taken to avoid the rancidity? Nitrogen gas. Okay, and which is a chemical which is used to avoid the rancidity? Which one will add it to avoid the rancidity? Antioxidants chemicals will add it to avoid the rancidity. So methods to avoid the rancidity and what is rancidity also to be remembered. And the rancidity is an example for what type of reaction? Oxidation reaction. Then final one is a corrosion. So as you know, this corrosion even we will learn in the metals and non-metals also. So any metal, if it is react with air, water, moisture or acid to form the undesirable compound called as a rust, and the process is called as a corrosion. So in the first chapter only two methods has been discussed to avoid the corrosion: painting, applying oil and the grease. Whereas more methods are there in the metals and non-metals chapter. Later we'll discuss that one. Okay, so this much things to be learned in the chemical reaction equation as a complete chapter if you want to memorize it. Okay, otherwise very important things if you want to learn, just cover this two: balancing of equation and types of reactions with example. And in that you have to cover all oxidation, reduction, thermal, electrochemical, photochemical, decomposition, all with the equations you should have to learn it. Then come to the second chapter of the chemistry is acid, bases and the salts. So first one is the general properties of acid and the bases. So here why I have gone through this general property, because in the model paper we have found few questions like acids they will turn which litmus paper into which litmus paper, and the bases they will turn which color litmus paper into which one. So acids they will turn which litmus paper into which litmus? Acids they will convert blue litmus paper into red litmus paper, and the bases they will convert red into blue litmus paper. Acids they have which ion? Acids they have H plus ion, and the bases they have which ion? OH minus ion. Acids are which taste? Sour to taste. Bases are bitter to taste. Okay, and the bases are soapy to touch also. Bases are soapy to touch. So this is the general properties of acid: which color to which one, their taste, and which ions are responsible for the acidic and the basic nature. Then next to that we will identify the given substance is a acid or a base by using that is another chemical called as indicators. And we have natural indicator, artificial indicator and olfactory indicator. In natural indicator, very importantly, remember about the turmeric powder. For the acid, there is no change in the color of the turmeric powder, but for the bases, it will turn into red color. Artificial indicator, two examples we have in the textbook. One is a methyl orange and another one is a phenolphthalein. So go through that color change. And the final indicator we have is a olfactory indicator. So that olfactory indicator is a onion, clove, vanilla essence. It is an example. What is the smell change? That you have to analyze it once for the olfactory indicators. Then second part of the lesson we have is chemical properties of acid and the bases. Chemical properties means which you have to learn. How does the acids they will react with the metals? So which gas has been released when the acid react with the metal? It releases which gas? Hydrogen gas. Which is a confirmatory test for the hydrogen gas? Popping test. Okay, so this diagram is related to the popping test only, and the confirmatory test for the hydrogen gas it is there. Okay, and even there is one applied question: why sour and the curd or the sour substances why we should not keep it in the metallic vessels? I think you are all familiar, because the same reason you will quote, because acid react with the metal to form, it releases a hydrogen and it forms the salt which is not potable. Hence we should not keep the acid or the source substances in the metallic vessels. Then the second property here as a chemical property is how acids they will react with metal carbonate and metal hydrogen carbonates. So if the acid react with metal carbonate or metal hydrogen carbonate, which gas will be released? Carbon dioxide gas. And which is the conformation test for the carbon dioxide gas? Which is the test? Lime water test. So as you will pass the carbon dioxide gas to the lime water turn into milky. Excess of carbon dioxide, if you pass further to the lime water, then once again the white color will be disappear. Okay, so that equation, so you have to glance once. Metal carbonate react with the acid, carbon dioxide gas will be released. Carbon dioxide, if you pass it to the lime water, it turns milky, and excess carbon dioxide once again makes the color to be get disappear. Then the next thing, it is neutralization reaction. What is neutralization? Acid react with base to form salt and water. Okay, so that equation HCl plus NaOH, it form NaCl plus H2O. That equations glance once for the neutralization reaction. And during neutralization, what products will be formed? That one. And another one thing, here when you are analyzing the neutralization reaction, metal oxides and non-metal oxides, all the metallic oxides are basic in the nature and they react with, if the metal oxides are basic, then they'll react with acids. Non-metallic oxides are acidic, then they will react with bases. Okay, so CuO plus 2HCl, that equation is related to metal oxide react with the acid. CaOH plus CO2, that is lime water on which we are passing carbon dioxide, is an example for base react with the non-metallic oxide, that is acidic in the nature. Okay, then a dilution concept, it is important. You are all familiar. That is whenever we dissolve a acid or base with the water, there is a decrease in the number of H plus or OH minus ion. It is called as dilution. Okay, if the acid is diluted more, what will happen? Acid become weak, H plus ions will be get decreases. If the base is diluted more, then OH minus ions will be get decreases and base become weak. Similar opposite question also can be appear. You have an acid, further if you add the acid, then H plus will be increased and acid become strong. If you have a base, further if you add the base, then OH minus increases and base become strong there. And there is one applied question, which is a correct method of dilution. Acid should be added to water or water should be added to acid? Water should be added to acid or acid should be added to water? Acid should be added to water. What will happen if we add water to acid? Reaction is highly exothermic and there is a chance that chemicals may splash and container can break. Hence, always during the dilution, acid should be added to the water, not water to the acid. Have you understood this one? So remember this dilution concept. Then definitely one question will appear from this part, that is pH scale. The strength of measuring, a scale of measuring strength of hydrogen ion concentration is called as a pH scale. Okay, now here, as you are all familiar, this pH scale start from 0, middle point is a 7 and end point is a 14. And in the pH scale, 0 to 6.9 is which pH? Acidic pH. Exact 7 is a neutral pH. Then from 7.1 to 14 is which pH? Basic pH. Okay. Whereas if you have a substances like, I'll just do an example. Observe, there are the two substances. Substance A pH value is a 4 and substance B pH value is a 5. In this, which is a strong acid? A is a strong acid, because if the pH value decreases, H plus ions will be get increases, OH will be decrease. Similarly, for the base, I will apply here one question. So observe, we have the two substance A and B. A pH value is a 9 and B is a 13. In this, which is a strong base? B is a strong base, because if the pH increases, OH minus also will be get increases. Okay, so don't forget to analyze the pH scales and related questions. And the pH in our daily life. Remember, pH in our mouth, then pH in our digestive system are important. pH in our mouth. So at what pH our tooth enamel will be get destroyed? Lower than 5.5. So to neutralize the pH, what we will use? Toothpaste. What is the nature of the toothpaste? Basic in the nature. Then hypersecretion of HCl in the stomach due to indigestion, it causes a problem of acidity. So to neutralize that problem, what we will take? Which chemicals? Antacids. Antacid nature is basic, mild basic there in the nature. And the common that is antacid example is magnesium hydroxide is a common antacid example. Have you understood this one? Then even consuming the chocolates, it is also that the sugar will be break down into acid due to the action of microbe in the mouth, and due to that pH will be lower to 5.5 and degrade our tooth enamel. And chemically our tooth enamel is a calcium phosphate, which is the strongest substance in the nature. Then acid rain, the rain whose pH is less than 5.6. Less than 5.6 is the pH of acid rain. If the soil is acidic, then you will add the basic salt. If the soil is basic, then you will add the acidic salt. So soil in the backyard, that also glance it once. Then which acid is present in which substance? That has to be glanced. Tomato, oxalic acid. Tamarind, tartaric acid. Curd, lactic acid. Lemon, citric acid. And ethanoic. In and which acid is there? Methanoic acid or formic acid also we can say it. Okay, so glance this, which acid is present in which substance. Then final concept to be learned is the salts and their uses. 100% sure, definitely one question will be there from this. But here also when you are learning, apply and learn as a applied base, that is they make an as sometime applied base question also. Salts and their uses. All the salts are basic in nature and their pH is merely equal to 7. And you know that how to make acidic salt, basic salt and the neutral salt. Acidic salt, how we can make? Strong acid, weak base. It become acidic salt. Strong base, weak acid, basic salt. Then weak acid, weak base, neutral salt. Strong acid, strong base, also it will form the neutral salt. So most of the salts are neutral in the nature. So common salt is a chief source to manufacture all the salt which is exist in the nature. So which is available in the ocean and even in between the rock, it is called as a rock salt. And that rock salt, it is found to be brown in color due to the presence of impurity as a sulfur. Okay. Then sodium hydroxide. It is prepared by which process? Chlor-alkali process. Chlor-alkali process. And in the chlor-alkali process, we will get the Three products, sodium hydroxide, hydrogen and chlorine. Learn the two uses of these three, sodium hydroxide, hydrogen, chlorine. The next salt we have is a bleaching powder. Okay, very important uses. But when you are learning, apply your brain and learn. That is how they can ask applied. They will give the use and they can ask you the which salt it will be. For example, name the salt which is used in the water treatment. For water treatment, which salt will use it? Bleaching powder. Like this, they'll give the use and they can ask it will be the which salt. Next, baking soda. Baking soda, baking powder, both are different. Baking powder is a mixture of baking soda plus tartaric acid, which is an edible acid. They will mix, then it will become the baking powder, which has been mainly used for the bakery industry. And even practice here when you are learning baking soda, what happens if the baking soda is heated? Carbon dioxide gas is released, and that carbon dioxide making the cake to become puffy and spongy. That also to be glanced, that equation. Then we have to learn washing soda. And the chemical name of the bleaching powder is calcium oxychloride. Chemical name of baking soda is sodium bicarbonate or hydrogen carbonate. Chemical name of washing soda is sodium carbonate decahydrate 10H2O. And their uses. It is used to remove the permanent hardness of water and the soap and detergent industry that you can apply there. Then water of crystallization. What is water of crystallization? The fixed number of water molecule present in formula unit mass of a salt. It is a water of crystallization. Copper sulfate is example. CuSO4 5H2O. And when you will heat the blue color copper sulfate, it become colorless. It is an example of water of crystallization. Once again, as you will add up the water, the blue color will be retained once again. Then last salt we have is a plaster of Paris. Chemical name is calcium sulfate hemihydrate. CaSO4 half H2. And it has been prepared by heating the gypsum. CaSO4 2H2. Did you got? So what happens if the plaster of Paris, if you expose to the moisture, or if you are not storing the plaster of Paris in the moisture proof container, that equation also to be glanced along with the uses. So if you are unable to learn the entire thing in the acid basis salt, at least focus this part, salts and their uses, and about the concept of the pH scale. Definitely question will appear from these two areas. Then the third chapter is metals and the non-metals. So one thing I'll say you here, as I said, we have 4 diagram, out of 4, 2 will come. And from this chapter, definitely one diagram will be there. And out of 2, 1. And here also out of 2, 1. But here compulsory from the metal one diagram will appear. Now here first part is the physical properties of the metals and the non-metals. So already I have seen in the state level preparatory the question have been came. List the physical properties of metal. And when you are learning the physical properties, even go through the exceptional points. Which are the exceptional point? Which metal you can cut with a knife? Sodium, potassium. Which metal have to be stored under the kerosene? Sodium, potassium. Which metal catches the fire and exposing to the oxygen? Sodium, potassium. Which metal loses the shiny property on exposing to the air? Sodium, potassium. See, for the single answer, how many questions are there? Similarly, which is the most malleable and ductile metal? Gold, and gold is the most malleable and ductile. Name the liquid non-metal. Bromine. Liquid non-metal, bromine. Name the non-metal who conduct electricity. Graphite. Name the non-metal which will shine. Iodine. Which is the best conductor of electricity? Silver. Poor conductor of electricity, mercury. Liquid metal, mercury and gallium. Are you getting? Best conductor of the heat, copper. So learn exception points when you are learning physical properties. Sonorous, malleability, ductility, high melting, boiling point. Okay, so that physical property, analyze it. Then chemical properties of the metals. In chemical property, diagram based on chemical properties there, that is action of steam on the metal. So whenever the metals react with the steam or with the water, it releases which gas? Hydrogen gas once again. Next to that, some points to be remembered here related to the reaction of metal with the water. Which metal float on water? Calcium and manganese. Remember, calcium and manganese, they'll float on the water due to which gas? Hydrogen gas. And copper. What happens if you heat the copper? It will form the metal, a next metal compound. On heating, it forms a black metallic oxide. So that question I have given you during the explanation. So about the copper equation, glance it. Then calcium, if you drop it with the water, what happens? You glance it. Then sodium, potassium react with the water, plus iron react with the water. This to be glanced in the chemical equations. If you want to practice in the metal, copper equation, then calcium equation, sodium potassium equation, and the iron equation. Plus along with this, we have missed one thing, that is amphoteric oxides. Amphoteric oxide. Few metallic oxides, they react with acid as well as with the base to form salt and water. Such metallic oxides are called amphoteric oxides. So zinc oxide and aluminium oxides are amphoteric oxides. So glance this definition with the example. Amphoteric oxide and with the example. And how aluminium oxide show amphoteric nature, glance the two equations also. Okay, then the chemical properties as it is been finished up. So some metals, they react very fast with the water, some of them they'll react very slow. The metals who will react very fast with the water are sodium and potassium. Metals that do not react with the water are gold, silver, platinum, copper. That one. And why? That is boilers are made up of copper, because the reason is copper, it will not react with the water immediately, so that only we will make the water boilers with the copper. That one. Then still, as it is been finished up chemical property, very importantly learn this reactivity series. I have shown one mnemonic way how to behead the reactivity series. So go through that one, because they can ask who is more reactive, who is less reactive. The next, ionic compound. How many properties are there for ionic compound? 4. Definitely the question can come. There are 4 properties of ionic compound. Ionic compounds, they have high melting, boiling point. Glance the give reason. Then second property is ionic compounds, they are hard in the nature. Give reason. Ionic compounds are soluble in water. There is no give reason for that. Ionic compound conduct electricity in liquid state. For that also there is a give reason. Have you got it? So glance this 4 properties, but only 3 give reasons are there. Then formation of ionic compounds are there. 4 formations I have taught you. One is this one, NaCl, MgCl2, Na2O, and MgO. Okay, in state level this one have not appeared. NaCl, MgCl2, Na2O, MgO formation have not appeared. So we can expect in the appearing exam. So they can ask the formations also. So glance this once, the formation of these 4 compounds. The next one, extraction of metals. In extraction of metal, Very importantly, learn the difference between roasting and calcination. I hope so that every one of you know that difference between roasting and calcination. Which type of ores will do roasting? Sulfide ore. Which type of ores will do the calcination? Carbonate ores. After roasting calcination, which is the next purification method? As the metals have, ores have undergone roasting calcination, what is the next step? Followed by reduction by using reducing agent. After roasting calcination, we will do the reduction, and the reduction will be done by using the reducing agent such as a coke. Then next to that, some metals we will purify by displacement reaction, but they have not highlighted as a displacement. It is been termed as a thermit reaction. In the state level, you have got that question. What is thermit reaction? Give example. And what are the applications of the thermit reactions? Then, when you are learning this extraction of metal, go through 1 mark definition. What is ore? What is ore? What is concentration of ore? What is gauge particle? That 1 mark questions also you have to glance it once. Then final concept it is after the extraction is method to avoid the corrosion. So they can have sometime a 2 mark question here. List the methods to avoid the corrosion. Painting, oiling, greasing, anodizing, electroplating. These are all the methods we have. But here in the avoiding corrosion, before to that 3 metal and the corrosion prevention was there. In one of the final paper, the question is there, how to avoid the corrosion, that is a corrosion of the copper, corrosion of silver, corrosion of iron. Corrosion of copper. Copper is corroded by which gas? What is the color? The color of copper is green if it is corroded, and the gas responsible is carbon dioxide. Compound is copper carbonate. The next, silver. Silver will be corroded by sulfur gas and the color will be black. Compound is a silver sulfide. Iron, flaky brown, moist air. Compound name is hydrated ferric oxide. Okay, glance this 3 metal, gas, color, compound which will be formed. Then as we gone through different methods to avoid the corrosion, in that anodizing or alloying. What is alloy? The mixture of 2 or more metal or metal and non-metal is called alloy or anodizing technique. So in that alloy, learn the compositions of steel, brass, bronze, solder. And which alloy has a low melting point? Solder, which is used to join the electrical wire because it has an application. So learn this solder. Along with that, glance about that is the composition of the steel, brass and the bronze. It is made up of what? And the normal iron is very soft, but we can make it too hard by adding 0.02% of carbon. As we will add, the soft iron becomes hard. Okay, so this is the highlighted things in this metals and non-metal chapter. If you can't learn everything, at least learn the 2 diagram from the metal. One definitely will appear. Plus go through this ionic compound formation and properties of ionic compound. Did you got it? Then finally, carbon and its compound. Here I can say, in this chapter you can't lose 1 mark also if you have studied entire content, which I have mentioned here. If you go through this one, you will not lose 1 mark also. I'll say how you can score out of 4 marks in the carbon compound. First thing is covalent bond formation. Here we have ionic bond formation and here we have covalent bond formation, sharing of electron. and whatever the properties you will write for the ionic compound, opposite properties you will write for ionic that is covalent compound. And when you are learning, learn dot structures, formation of O2, N2, CO2, H2S, F2. This formation is a dot structure formation in the covalent bonding. Then very important and most repeated question, difference between saturated and unsaturated hydrocarbon. I think every one of you know that difference between saturated and unsaturated. Then when you are learning here, learn the structures of saturated and unsaturated. And I have told in one of the class, and I have mentioned also, no need to practice the entire structures. If you are learning alkane, learn till the structures of butane, it is enough. In alkane, CnH2n plus 2. In alkene, if you are learning, learn from ethene to butane, because in the textbook that much structures only are there. They can't give any question out of textbook, so that only I am saying. If you are learning alkyne structure CnH2n minus 2, learn from ethyne to butane, it is enough. Did you got? No need to practice any extra structures in saturated, unsaturated. That is methane to butane, ethene to butane, ethyne to butane. It is enough. Then in cycloalkanes, you have four structure: cyclopropane triangle, cyclobutane rectangle, cyclopentane pentagon, cyclohexane hexagon structure. Then only one structure you have to learn here for aromatic hydrocarbon, and 2 times it have been repeated in your preparatory, benzene structure C6H6. And difference between benzene and cyclohexane: benzene is aromatic, cyclohexane is non-aromatic. Benzene is unsaturated, cyclohexane is saturated. Benzene has a alternative single double bond, but cyclohexane has single bond between carbon to carbon. The difference you can write up. Then along with that, here I forgot one thing. Learn definition of catenation with example, property of self-linkage of carbon, straight chain catenation, branch chain catenation, closed chain. Then isomerism with example, N-butane, isobutane structures. Isomerism. Compounds have the same molecular formula but different structural arrangement. Sometime to make you confused, I will give you the word. What is structural isomers? Give example. Structural isomer means same thing which I have learned in your syllabus. Then here, from this 100% sure question will come functional group, because all preparatory paper you take, all the model papers if you have glanced, you are getting the question from the functional group. Either identification, otherwise they'll give the structure and they'll ask which it is the functional group present. And apart from that one, another one thing in the functional group, if they ask to write the structure, which structures we had to practice in the functional group. If you are not noted, note this and keep it in mind. In alcohol, only practice methanol, ethanol, enough, because only 2 structures are there in the textbook. In carboxylic acid, practice only ethanoic acid. Then in the aldehyde, practice ethanol. Then in the ketone, practice propanone. Whereas chlorobromo, halo functional group which you have, till they can ask bute. Till the butane they can ask anything, that is a chloropropane, bromo, butane, bromopropane, anything they can ask, so that if you are good with alkane from the meth to bute, if you are familiar, then you can write the chlorobromo very easily. Did you got? This is enough. Structure, this much it is enough, whichever I have told. No need to practice any additional structures in the hydrocarbons. Then homologous series. I think every one of you know how to do homologous series, verification type of questions. They'll give either saturated one formula and they'll say verify or write the four successive member. Did you have remembered this type of questions of solving homologous series? Okay. Then out of six definitions here, out of six definitions and six reactions, compulsory will get one here. Which are those? Let's glance it. First one we have combustion. Saturated they will undergo complete combustion, unsaturated they will undergo incomplete. Saturate and the complete combustion will be carried with the excess of oxygen, incomplete will be carried with the limited supply of oxygen. And the complete combustion release the blue color flame, incomplete combustion it will release the orange or yellow color flame, that you can glance up. Then one reaction is there, how saturate hydrocarbon undergo complete combustion. CH4 plus O2, that equation you have to glance. The next one is substitution reaction. CH4Cl2, that equation. From that, it is a second reaction to be practiced. How saturated hydrocarbons undergo substitution reaction. Give example. The next one, addition reaction. Last year in the final, this reaction have been came. Converting which hydrocarbon into which hydrocarbon? Converting unsaturated hydrocarbons into saturated hydrocarbon by passing which gas? Hydrogen gas, and using which metal? Nickel metal as a catalyst. Okay, otherwise converting the liquid oil into solid fat. It is also the addition. For the for that we will use the hydrogen and nickel, and the palladium metal we will use it as a catalyst. What is catalyst? A substance which increase the rate of reaction. That is a catalyst. Which makes the reaction to be done faster. It is a catalyst. It is there. Okay. The next one here, oxidation. Here two things you have to learn. What is oxidation reaction and oxidizing agent? What is oxidation reaction and what is oxidizing agent? A chemical substance which is used to add the oxygen is called oxidizing agent. Example, acidic K2Cr2O7, potassium dichromate, and alkaline potassium permanganate, KMnO4. Do you know that oxidation, converting ethanol to ethanoic acid is a oxidation because there is a addition of oxygen. The next, dehydration, a chemical reaction in which there is a removal of water. Conversion of ethanol to ethene is a dehydration, and the dehydrating agent is a concentrated sulfuric acid. As we'll add the sulfuric acid, there is a removal of water, hence it is a dehydration reaction. Then final one is a esterification reaction. Ethanol react with the ethanoic acid to form, sweet smelling substance called ester. It is called as what? Esterification reaction. Okay, so glance that what is esterification reaction with the equation. Saponification is also there. Saponification, that is esters on treating with the strong alkali bases like a sodium hydroxide, it will forms a soap or salt of carboxylic acid. It is called as saponification reaction. Then final thing to be learned here, it is a soap and detergent difference. Soap and detergent difference, cleaning action of the soap. Cleaning action of soap. And what is a scum? Soap react with hard water to form insoluble substance called as scum, that one. And which salts are responsible for the hardness of water? Calcium and magnesium salts there. Okay, so if you are unable to learn the entire thing, at least focus this saturated, unsaturated structures, functional group structures and identification, and this 6 reactions. Definitely the question will come from this saturated, unsaturated structures, functional group, and this 6 reactions with the examples. So this much you have to cover for 25 marks in the chemistry. Okay, equations are you are finding very tough. That is which equations we have to be remember in practice means from the carbon compound the equations can be asked related to that is addition reaction and oxidation reaction and a dehydration reaction. Here in the metals and non-metal, reaction with the water, reaction with the oxygen, then amphoteric oxide equations, thermic reaction equation. In acid base salt, which equations? That is acids if they react with metal carbonate, hydrogen carbonate, that equation, lime water test equation, and along with that final in the acid bases and salt, heating baking soda, reaction of plaster of Paris with the water, that equations to be practiced here. But here in the first chapter we cannot predict. It is very important when you are practicing types of reaction with example, focus on all the equations. It is a mandatory for you. Have you got it? So this is a important thing to be covered up. So go through this one and finish up the revision of the part B chemistry. Apart from that, any doubt is there? Nothing. No doubts. That's it.